Hello, I'm Anna Mackay and today we're looking at sketching graphs directly. So here's our basic parabola with the format y equals ax squared plus bx plus c. Thinking about some of the significant features on this quadratic, we've got arrows pointing at some particular spots. What are they called? The x-intercepts. And what's the value of that x-intercept? How can we work that out by that quadratic there? And what about that one? What's the value of the x-intercept on that side? Ha! The quadratic formula. This is something I'm hoping you know off by heart and can recite basically in your sleep. So by solving that, you may or may not know that it's x equals for that formula. Why is it x equals? Because it's giving us the values, the two values, because the plus or the minus counts for that, of the x-intercepts. A lot of people often when they're working it out just write equals and do all the working out, never writing that it's x equals. So that's something to remember. And that simplifies down to this version with this symbol underneath the square root sign. Do you remember what it's called? Starts with a D. It's the symbol in the Greek alphabet called delta. D for delta and D for the discriminant. And think about the word to discriminant or discriminate, but in this context it helps us to look at the difference between the different quadratics that could happen based on that discriminant value. So the x-intercept on the right hand side in the positive region, it actually doesn't have to be positive, but it's one on the right, will be the plus version of this, and the one on the left will be the formula subtract the discriminant. So having a think about what the different values are that the discriminant could take. And that's the thing that discriminates between the x-intercepts. Think about if that wasn't there. What would you be left with in that formula component of this? What would be left if the discriminant part wasn't there? Well, you'd be left with, let's have a think about this here, the negative b over the 2a. Technically the plus or minus sign, but that bit's not going to matter. So that would actually be halfway between the 2 points, because we would start in the middle, and then the thing that discriminates between them is how far left or right that we move, and that's the bit that changes. So there must be some middle sweet point, so to speak, between them, and that's our axis of symmetry. And that has the form negative b on 2a. So it's the part that's left over when you're not discriminating about where the x-intercepts are. So interesting point there. Summarising some of the points here for graphing quadratics. What options have you got available to you? You can find the axis of symmetry. What was that again? Which coefficients of the quadratic help you with the axis of symmetry? Negative b divided by 2a. And as we've just talked about, that's part of the quadratic formula. Negative b on 2a. Substitute that value to find the y coordinate of the vertex. So you think coordinates have 2 points, an x point and a y point. If we have the x component of the vertex, you substitute that number in and that will tell you the turning point coordinate, the y value, be it a minimum or be it a maximum. Next, the y-intercept. That means x is equal to 0, and so looking at that form of the quadratic, if x is equal to 0, those parts cancel out, so our y-intercept must be c, or as a coordinate, 0, c. Also, the x-intercepts. Now, how do we find them? What did we talk about at the start of this video? You've got two options. You can factorise. That's if it's got nice, neat factors that factorise neatly, or using the quadratic formula. In this sense, you don't need to complete the square. Yes, that turns it into one factorised form, but that's not going to help you in terms of finding the x-intercepts. All right, let's get on to one example here. So we've got this quadratic. First of all, it's asking us to find the axis of symmetry. Now, so thinking back to what formula we had for that, x equals what? We have x is equal to negative b on 2a. A thing that I find really handy to do is just state what your coefficients are, because you often do need to use them in questions. And if you've got these written out, it can avoid some confusion later on. So our axis of symmetry is negative b, so we've got negative 8 on 2 times by 2 is negative 2. So that's our axis of symmetry, or AOS, sometimes referred to. Tick, done that one. Part B, find the coordinates of the vertex. Now the vertex has the axis of symmetry in it. That's the x component. So for the vertex, we substitute in, sub in x is equal to negative 2. Sub it in where? Into the formula, to the equation of y equals. So where you see an x, we're going to substitute in a negative 2. And brackets are always very handy here to account for those negatives. Working that out is negative 18. Classic. Don't stop there. Go back and read the question. What did it ask you to find? The coordinates of the vertex. So you're actually being assessed on your skill to read the question and not just leave it as negative 18, but to state that as coordinates. So there we are, we've done that one. Now, part C, find the axis intercept. So that's where the other one is equal to 0. The y-intercept is always easy to find. Why? Because it's this number here. Get into the habit of writing that as coordinates, because when you come to plot these graphs, if you've got a pile of coordinates, it makes it really easy to work out where to graph it. So there's our y-intercept. What about our x-intercept? What options have we got for x-intercepts? Yes, you can go to quadratic formula and everything will work instantly by default, but it is handy to practice your skill of factorising on these simple ones. That looks fairly straightforward, so let's go that a bit further. Now, x-intercepts are of the form where y is equal to 0, so we can put that in. I'm seeing a common factor of 2 here, so I'm going to divide straight through by 2. You can factorise that out as a bracket, and that's fine too, but if it's equal to 0, you can divide through and get rid of that common factor. Now, I'm thinking that looks pretty straightforward. I've got 2 factors here. I look at my negative 5 there, think what multiplies to give negative 5? A 1 and a 5. But we need one of them to be negative. So then we look at that 4 and think, if I had positive 5 and I subtracted off 1, then I'd get that 4. So therefore our x-intercepts are 1 and negative 5. I like to write that as coordinates. And there we have it. Go back and read the question. Yes, we've found the axis intercepts. And part D, we have to sketch. So this is where having a set of coordinates comes in really handy. Look at your x values that you've got across your coordinates. Here on this screen we've got a 0, we've got a a positive 1 and a negative 5. And from the axis of symmetry we had a negative 2. So we need values for x ranging from positive 1 down to negative 5. So that's how far we've got to go. What about the y values across these coordinates? We've got zeros here, negative 10, and on the axis of symmetry we had negative 18, so all the way down there. May also be worth thinking which way is it going to turn, concave up or concave down. You look at the coefficient of x squared, the a value there, it's positive, so that's positive is happy, so it's in a happy smiling shape. So graphing this using your ruler, arrows, we decided we had lots of negative numbers in the y region, so that's why we're going to graph it in this way. What numbers are we putting on there? We have our x-intercepts of 1, so 1 there, and negative 5, 1, 2, 3, 4, 5. Because it's only a sketch and it's not draw, we don't have to be exactly precise. We don't have to label every single number on the axis there. What else have we got? The y-intercept is negative 10, and the vertex is down at negative 18 for y and negative 2 for our x. Negative 2 there, negative 18 for v. That's our turning point, and our axis of symmetry is x is equal to negative 2. So now when you come to draw this with a pencil, you've got to turn down at the vertex, you've got to cut through the x-intercepts and the y-intercept there and connect your dots, so to speak. I like to put a second dot in there and put arrows on the end. And it's always good form to label what that line is. Give it a name, 2x squared plus 8x, take 10. Or you could have it in the factorised form, but why reinvent the wheel when it's already written for you there? Okay, so make sure you subscribe to the channel, and the next video in this series, finishing off the sketching different versions, we'll look at the discriminant and positive, negative, definite graphs. Thank you.